Hello class, let's continue our lesson on chapter 2 multivariable function, definition of partial derivatives and mixed derivatives. So as you can see here, this is how we differentiate between the variables. Okay, previously for a single variable we differentiate like this. Okay, this means differentiate with respect to x. Okay, currently now we are learning that differentiation can be more than one variable, and it should be written as this, which is this will differentiate with respect to x and differentiate with respect to y. So we let the function to be z equals to f, x, and y. So the partial derivatives means we need to differentiate with respect to x and with respect to y. So all of this you can see is the formula or what this should be written when we want to differentiate between with respect to x, and this also differentiate with respect to y. So here we can see an example of a function of 3x minus 2y power of 4. The solution is fx will be the differentiation with respect to x. So you can see here 3x will be 3, and fy will be, we take into 2y power of 4. So if you differentiate this, it should be 4 times 2, and 4 minus 1 should be 8 power of y power 3. Okay, so don't forget that there's a negative sign, so it should be negative 8 y power of 3. Okay, here you can see a function of fs and t. So these are the variables. So if you want to differentiate, so you can see this is to differentiate with respect to s. So this will be the differentiation with respect to s. Okay, so how we do this is that f s t. So what happens, you can write this t multiply with s1 and s t negative 1. Okay, so if we differentiate with respect to s, so this will be negative 1 multiply with t, and s1 minus 1 would be 1 minus 1 means this 2, negative 2. Okay, so here will be just t minus 1, t power negative 1. Okay, so if we rewrite this, it should be negative t s square minus 1 over t. Okay, for the second one, this is with respect to t, so we differentiate all of those with respect to t. So this will be the answer. Okay, so let's take a look at another example. So keep in mind we have to follow the example such as this. Okay, where we need to follow y equals to uv. Okay, so what does u represents, what does v represents? U and v represents the variables of x and y. Okay, so you can see if you have something like this which represents something like this. Okay, so in this case u can be x and the v should be e x x 3y. Okay, so what we need to do in step 1 is to find, okay, the question is find fx, which is the differentiation with respect to x, and fy, the differentiation with respect to y. So first of all, step 1 is to differentiate with respect to x. That means we look only on the x variable. Others are constant. So fx, alright. So what we do first is that we differentiate in terms of u. Okay. So let's follow what is written here. Okay. So we have u equals to x and v equals to ex power 3y. Okay. So let's write this as fx okay, equals to so let's put u dv over dx. Okay, so what is u? U should be x, all right, and dv dx should be written as okay, so dv dx should be calculated as okay, how do we differentiate this? Differentiate, let's say this one. Okay, how do we differentiate this? So to differentiate this, so let's say I put this as y equals to okay e x power 3 y. So dy dx should be 3x power 2, okay, and y, and multiply with e x 3y. Okay, so this is how to differentiate power with respect to x of x power 3y. Okay, so we can write this as 3x 2y and keep the same formula again. Okay, alright, then we need to plus with v du dx. So what is v? Plus with, we need to plus with e x 3y multiply with what is this? Du dx. So du dx will be differentiate this, so you get 1. Okay, so what we get is this. Alright, then we take a look at 4x. For x will be 4. This one will be 0 because there's no x variable, and this will be 2. So 8x 1 power 1 times y power 4. Okay, so simplify and you get this is the derivative with respect to x. Okay, and evaluate each point at point 1. So you can see this is x value, this is y value. So substitute the values into the x values and y values. Automatically you will get an answer such as this. Okay, then we need to differentiate with respect to y. Again, use the same equation such as this. Okay, so let u be x and v be the e x 3 4. Okay, again you need to differentiate this. Okay, differentiate this so it will become this value. Okay, and the rest will be differentiate in terms of y. Okay, and substitute the values and you get an answer like this. Alright, so for second order partial derivatives, it means that we need to differentiate twice. Okay, for example, for first order, meaning we differentiate once. Okay, so that means like dy dx. For second order, it will be d square over dx square. That is second order. So let's take a look at that. examples. So here are the notation for second order partial derivatives. So you can see these are the notations or the symbols to differentiate uh, 2 times with respect to x. Okay, and here you can see differentiate 2 times with respect to y, and here you can see differentiate with respect to x and then y. That means differentiate with respect to x first, then differentiate with respect to y. And here will be differentiate with respect to y, and then differentiate with respect to x. Okay, so it should be in order such as this when you have this kind of symbols. Okay, so here is another example to determine the second order partial derivatives. So here is the function of fx. What we need to do is we need to differentiate in terms of fx, means differentiate with respect to x first. Okay, so fx, take only the x variables, excuse me, and then fy differentiate with respect to y, and we differentiate the y variables. Okay, so once we get the differentiation with respect to x, we can differentiate another time with respect to x. Okay, so you can see here, how do we get this is that by taking fx equals to 15x to y power 3. So fxx will be taking 8 times 3, 24, x power 2. Then here 15 times 2 is 30, x y power 3. Okay, so that is the difference with respect to x for 2 times. Then we have differentiation with respect to y for single time. Okay, and fyy is to differentiate y with respect to y the second time. So here will be negative 30 x3 y minus 12y squared. Alright, so if f x y is where we can differentiate x first. Alright, so we have fx, which is equals to 8x 15 x squared y cubed. So fxy is to differentiate with respect to y. So this will be 0, and 15 times 3 times 15 will be 45 x squared y 2. Okay, and the last one will be, let's take fy, which is negative 15 x3 y2 4y2. So when you do fy, sorry, this should be fx, huh? So fyx, then you differentiate in terms of fx, okay, or with respect to f. So negative 45 x squared y2 4 y. No, so this will be 0. Okay, so this will be your answer. This will be 0. So here is another example of the second order partial derivatives. Right, so here we can see there's the function. So first of all, we need to differentiate it the first time with respect to x. Okay, so we can do this by taking u, v, and yeah. Okay, all right, so what we can do is first differentiate with respect to x for this side. Okay, so let's put this as dy dx. Okay, so we have u dv dx plus with v du dx. So what is u? Okay, we can write x, and dv dx will be okay, to differentiate 2x plus y. To differentiate this, first we must differentiate the whole outer part. Okay, so it will be -1. Okay, and then differentiate the inner part, which is 2x plus y. So you can see 2x will be 2, and then that's all. Okay, so that's all, and we need to write the existing part back lah. So y -2. So this part you have to add -1. Okay, -1, and you give 2 here. Okay, and the v part will be 2x plus y -1, and du dx will be differentiate x, so x will be 1. Okay, and it is written here clearly. Okay, and then we need to differentiate this, which is differentiate sine. Okay, so what we need to do is to differentiate with respect to x, differentiate sine to x will be sine will be cos. Okay, since there's no power of anything, it should be given as 1, so only y is existed lah. Okay, so when we comply with everything, you have an answer such as this for the first derivatives. Okay, so for the second derivatives, we do the same thing by using the rule, this rule, in calculating the second order with respect to x. Okay, so we differentiate everything with respect to x, and then multiplying by everything, we get this answer. Okay, then for this, differentiate with respect to x, then only differentiate with respect to y, then you'll get this answer. Alright, okay, so here is an exercise you can do yourself. Okay, let's try the first exercise, which is to find the first order partial derivatives. Okay, and given the values of the points, so let's differentiate fx. That means differentiate with respect to x. So we take everything all with the x variables, and those without x, it becomes constant and it becomes 0. Okay, so the answer will be 4x power 1 minus 6x power 1 multiplied with y. This will be 0, this will be 0, this will be 0, so the rest will be minus 1. Okay, so given to you that f01, substitute the values of x equals to 0, 6, 0, 1 multiplied by minus 1. So the answer will be -1. Okay, and fy, so let's take a look at fy. That means differentiate with respect to y, so the rest will be 0, and this will be 1, so 3x 2, and here will be 2y plus 2y and plus y plus 1. Okay, so if fy is 0, so this is fx, so fy is 0 and 1, so we substitute the values, 3 0 plus 2 1 plus 1. So the answer will be 3. Okay, so it's correct. Alright, so let's take a look at the second question. So our fx y, the function is this. So we have to find what is fx x. So first of all, we need to differentiate in terms of x fx. Okay, so to differentiate this, that happens, it becomes 2x y power 3 plus 4x power 3 and y. Okay, and fx will be differentiate with respect to x again, so 2y power 3 plus 8, sorry, 12 x power 2 y. Okay, then if you want to do fx y, that means taking the fx, okay, taking this first order, then differentiate according to y. So it will be 6x y power 2 plus 4x power 2. Okay, so we have solved these two. Okay, and for f for x, let's say we need to differentiate in terms of y first. Okay, so to differentiate in terms of y, this will be x2 3y power 2 plus with x4. So fyx will be 2x 3y power 2 4x power 3. Okay, so fyy will be x power 2 6y plus 0 plus 0 lah. Okay, so this will be the answers. So here you can see it's a chain rule, where previously we can use the formula of getting the function or do the differentiation of dy dt. So dy dt will be dy over dx, dx over dt. And then if you have multivariable function now, the differential function of x and y, where x is gt and y is ht. So the equation might be this now. Let's take a look at the example for a clearer picture. So here is the chain rule, where a function of z equals to x squared plus y squared, but x squared is equals to 1 over 2 and x is equals to 1 over 2 squared and y equals to 2t 1t squared and y equals to 2t power of 3. So find what is dz over dt. So to find dz over dt, we need to use this formula. What this shows is that we first need to differentiate in terms of dz over dx, then we differentiate in terms of dx over dt. And then similarly, we have to differentiate dz over dy and dy over dt. Okay, so this will become, so let's differentiate what is dz dx. Okay, so this will be 2x, and then differentiate dx over dt. This will be the equation. So this will give you negative 2 over t power of 3. Okay, so we substitute the values in here and we get the values. Similarly, we do dz over dy with respect to y. So this gives us 2y, and dz over dt, sorry, dy over dt will give you 6t 2 power 2. Okay, so you add up both inside, and then when you add up all together, okay, the x here we need to substitute with this value, and the y here we need to substitute with this value. Why? Because it is given here x equals to 1 over t2, t power of 2, and y equals to 2t power of 3. So you substitute the values inside this equation, and this will be your final answer. So this can be used by calculating the rate of change. Okay, so the rate of change of the multivariable function can be written just like the chain rule as explained before. Here is an example of the application on how you can use the differentiation where we can find the rate of change. So here is the rate, how to find the rate of change of the volume of a right circular cone. We have radius, this is r, and height h. If the increasing rate of radius, what does this mean is that it is considered as dr over dt, and the decreasing rate of height is called dh over dt. So the rate of change for that volume is dv over dt. Okay, so the formula for a right circular cone, volume for right circular cone, is this. So the rate of change of the volume due to the rate of the radius and rate of height can be given as this with the using chain rule. Okay, so we need to consider what is dv over dr. Okay, so dv over dr is considered differentiate with respect to r. So it will be 2 over 3 pi r h. Okay, then we need to consider dr over dt, which is already given as 1.2, and then dv over dh, where we need to differentiate with respect to h, which is given as 1 over 3 pi r square. Okay, and dh over dt, which is negative 0.5, because it is mentioned as decreasing. Okay, so we substitute the values all inside, as we know that this will be the differentiation, and this, let's say r, what is r will be 10, h is 30. Okay, and this is d r over dt, and this okay, plus with 1 over 3 pi r dh over dt. Okay, so this will be our answer. So the rate of change of the volume is 73 times 1 over 3 times pi.